So now looking at question 2, 2.1 says that given the quadratic pattern of minus 22, minus 20, minus 12, minus 6, and minus 4. So in 2.1.1, we are asked to write down the next two terms of the pattern. So we need to find the next two terms of the pattern. So to find the next two terms, we have minus 22 and minus 12, minus 6, minus 4. So we need the next two terms of the pattern. So the first thing we're going to do is we're going to find the difference of these numbers here. And the first difference we're going to have is 10. The second difference is 6. The third difference is 2. Then we find the second difference of the sequence, or the pattern rather. The second difference is going to be minus 4. So as you can see, it's common throughout. So it means that it's going to be common here, it's going to be common here. So what you need to do is we need to find the terms of the first difference here. So how we're going to get them is we're going to say this minus 2. So to find them, we're going to say that this 2 here plus this minus 4 is going to give us what? It's going to give us minus 2. And we're going to add this minus 2 with this minus 4 to get a solution of minus 6. Then now to find these terms here, we're going to say minus 4 plus minus 2 is going to give us minus 6 here. And this minus 6 plus this minus 6 is going to give us minus 12. So your next two terms is minus 6 and minus 12. 2.1.2, we are asked to find the expression of the nth term of the pattern. To find our nth term, we need to first write down our sequence that we wrote in the previous question. So we're having our sequence here, and our first difference of the sequence is 10, 6, 2, minus 2, minus 6. And the second difference of the sequence is minus 4. So minus 4 is constant throughout. So to find the nth term, we're going to say 2a is equals to the second difference, which is minus 4, divided by 2 both sides, and then a is equals to minus 2. Then 3a plus b is equals to the first term of the first difference, which is this 10 here. So it's going to be 10. Then you know our a is equals to minus 2. So 3 into minus 2 plus b is equals to 10. Then we transpose this portion here, which will give us a solution of 6 plus b is equals to 10. Transpose the minus 6 to the other side. We have b is equals to 10 plus 6. Then our b is equals to 16. Then now what you're going to do is going to say a plus b plus c is equals to our first term of the pattern, which is minus 22. So it's equals to minus 22. So where we substitute for, so now the value of a is minus 2, so it's going to be minus 2 plus the value of b, which is 16, so it's plus 16 plus c is equals to minus 22. Then you transpose these two values to the other side, and the solution of c is going to be equals to minus 36. So now we're having our value of a, which is equals to minus 2. We have a value of b is equals to 16, and our value of c is equals to minus 36. Remember that our Tn is equals to an squared plus bn plus c. So we're going to substitute our values. So a, we're going to say minus 2n squared plus 16n minus 36. So this is the nth term of the number pattern. In 2.1.3, we are asked to write down the term of the pattern which has a maximum value. So now we are asked to find a term that has a maximum value. So what we need to do is we need to first write our nth term, which is minus 2n squared plus 16n minus 36. So to find the n value at its maximum, normally we use our turning point, which is equals to minus b over 2a. Why are we using our turning point? Because we're talking of a maximum value. And remember that when you talk of maximum or minimum, and looking at this, it is an equation of a parabola. So if you draw your parabola like this parabola has a minimum value here at y, right? And if you draw a parabola looking down like this, it has a maximum value. So the minimum and maximum is defined by your value of a. So if a is less than 0, then your graph of a parabola will have a maximum. If your a is greater than 0, then your parabola will have a point of minimum. So our parabola here is a point of maximum because our a value is less than 0, which is a is equals to -2, as you can see here. So we're going to find the value of n when the graph is at a point of maximum. So it's going to be x equals to minus, so our b is 16, and divide by 2 into our a, which is -2. So our x values, we're going to get 4. So meaning that n is equals to 4 when this graph is at a point of maximum. In 2.2, we are given the nth term as Tn is equals to 27 minus 6 into n plus 1. So we are asked to find the common difference of the term. So we're having Tn is equals to 27 minus 6 into n plus 1, and we're asked to find our common difference. Just take our common difference, which is this one, because it always multiplies our equation here. So which you can simply say d is equals to -6, which is your common difference. In 2.2.2, we need to write down the term of the sequence that is equals to -117. So now what you're going to do is we are given Tn as -117, and we have our Tn, which is 27 minus 6 into n plus 1. To find the n value, we're going to equate the -17, so it's -117, sorry, equals to 27 minus 6 into n plus 1. Then we're going to transpose the 27 to the other side. We have -117 minus 27 is equals to -6 into n plus 1. Then we're going to divide by -6, divide by -6. We have n plus 1 is equals to -117 minus 27 over -6. Then what you need to get is you're going to say n equals to, so you're going to transpose the 1 to the other side. You have -117 minus 27 over -6 minus 1. So your n value is going to be equals to 23. So now in 2.3, we are given the series here of 5, 9, and 13, which consist of n terms. The sum of the last 6 terms. So the sum of the last 6 terms of the series is 906. So in 2.3.1, we are asked to determine in terms of n the sum of the n terms of the series. So you're going to find the sum of n terms of the entire series. So here what we're going to do is we have our series, which is 5, 9, and 13, right? So to find our sum of n terms, what you're going to do is we're going to first find the difference of this sequence here. And the difference that you're going to get is 4, which is common throughout. So our sum of the series is equals to n over 2 into 2a plus into n minus 1 d. So why is this? Are we using this sum? Is because we have identified that this series here is arithmetic. Right, so if it's arithmetic, how do we see that? We see it with this common difference. And so what you're going to do is we're going to substitute into our sum here. So we don't have our n, so it's going to be n over 2 into 2. Instead of writing a, we're going to write this 5 here. So it's going to be 5 plus into n minus 1. Our d is going to be 4. So what you're going to do is we're going to multiply everything, but before we multiply everything inside, let's solve everything inside here. So we're gonna have equals to n over 2 into 2 multiplied by 5 is gonna be 10, and then the 4 we multiply everything that is inside, so it's going to be plus 4n minus 4, and then we have equals to n over 2 into, so we're gonna add and subtract this. 10 minus 4 is gonna give you 6 plus 4n, and then you multiply the n over 2 inside, so we're gonna have 6n over 2, right, plus 4n squared over 2. So your solution of your sum is going to be 3n plus 2n squared. So this is our sum of n terms. 2.3.2 says that if the last 6 terms of the series are excluded, determine in terms of n the sum of the remaining terms. So now if they say that the sum of 6 terms which are excluded, which is equals to 906, and to find our solution here is we're gonna say the sum of n minus 6, so we are subtracting the 6 terms. It's gonna be equals to our sum that we found in a previous question minus the sum of 6 terms that are excluded. So meaning that the sum that we found in the previous question was 2n squared plus 3n, and then we subtract the 6 terms, which is we're gonna just subtract with this number here, so it's gonna be minus 906. So this is the sum of n terms minus the 6 terms. 2.3.3, hence determine the value of n. Now we want to find the value of n. For us to find the value of n, we need to first write our sum excluding the 6 terms, right? So how do we find it? We found that in the previous question to be 2n squared plus 3n minus 906, right? So let's consider this as our equation 1. Why? Because we can still find the sum of n minus 6 in another way. So what we want to do is we're going to say the sum of n minus 6 is equals to, we're going to substitute that in our sum, which you remember very well that our sum was equals to 2n squared plus 3n. So we're going to say the sum of n minus 6 is equals to 2 into, so instead of writing this n squared, we're going to say n minus 6 squared plus 3 into n minus 6. Then we expand this expression, so it's n minus 6 plus 3 into n minus 6. Then we're going to find the product of this expression here. So it's going to be 2 into n squared minus 6n minus 6n plus 36, plus, then you multiply the 3 inside, you will have 3n minus 18. So the sum of n minus 6 is equals to 2 into n squared minus 12n plus 36 plus 3n minus 18. So when I multiply the 2 inside, we're gonna get 2n squared minus 24n plus 72 plus 3n minus 18. Then we're gonna collect like terms, so it's gonna be 2n squared, then you collect the like terms, these two, minus 24n plus 3n, and then these like terms here, so it's going to be plus 72 minus 18. Then your sum of n minus 6 is equal to 2n squared minus 21n plus 54. So this is your sum of n excluding the last 6 terms. So let's equate this to equation 2 because we already have equation 1. So what you need to do is we need to equate equation 1 with equation 2. Remember that equation 1 was Sn minus 6 equals to 2n squared plus 3n minus 906. See, this was equation 1. So let's equate these two equations here. So equation 1 is equals to equation 2. So because we want to find the value of n, hence we are equating them. And they are equal since it's the sum of n minus 6. So the first equation is going to be 2n squared plus 3n minus 906 equals to, and then our second equation is going to be and then our second equation is what we just found here, this one here. So it's going to be 2n squared minus 21n plus 54. So what you're gonna do is, this is the like term of this one. If it's transposed to the other side, it's going to be negative, so they're gonna cancel out. Then we collect these like terms here. So we transpose the minus 21 to the other side, we have 3n plus 21, and then you transpose this 906 to the other side, the negative 906 will have equals to 906 plus 54. And then if you add these two, you're gonna get 24n is equals to 960. Then you divide by 24 both sides, you have n is equals to 40. So these are your number of terms.